So if you just joined us on the recording, just had a little look at the start question that I posted up there. If you want to have a read through that, you can do. We're going to do a very similar example to this in a second that's in your booklet. Before we continue, just remember that the binomial normal distribution test is going to be on Friday the 22nd of May, so that's next Friday. So there'll be no lesson next Friday because you're going to be doing the test instead at 11 o'clock. You'll have an hour to complete that test and then half an hour to take photos to send us back to Mark. So before that, what you need to do is fill in the form that is on the general page on the team. If you haven't already, just letting us know that you understand that that's when the test is, and just basically confirming attendance, and that you'll let your tutor know that if that is a problem making that time or you're going to have any issues there. So really important that you do that as soon as possible, please, hopefully by the end of this week, so we know if there's any issues there. Today's lesson is going to be all about modelling. So modelling with the series and sequences that we've done so far. And this is because, generally speaking, most of the questions in your exams on sequence and series often, pretty much 95% of the time, there will be a modelling style question on this. So it will be quite a wordy question. Very rarely will it say the first term is this, the common ratio is this, tell us the sum. It will usually just kind of put it in some kind of context. So this first problem is very similar to what we looked at the start. So first question is, work out the thickness of the paper after 4 folds. So in this question, we're told the thickness is 0.5 millimeters. So for the first question, we're going to set up a formula here. So to find our nth term, we have our first term, which is 0.5, and then we times it by the common ratio. A little bit like our first example, normally we'd times it by the common ratio to the power of n minus 1, but here I'm just going to put to the power of n. You could call that first term u0 and then use n minus 1 here if you wanted to instead, if you want to be consistent. So it's up to you whether you want to use what we've done before or just kind of apply a bit of logic here, in that each time you fold it, you're going to double the length, so you can just use n as the number of folds here. Or if you want to kind of keep it consistent with terms in the sequence, you could start the first term as u0 rather than u1, and then u1 is the first fold, u2 is after the second fold, and so on. So to find u4, I just do 0.5 times 2 to the power of 4, which just gives me 8 millimeters. So I've set up a formula and then just plugged in n. So it's about extracting the information you've got in the question into a formula and then simply just put the numbers in. And for part B, work out the thickness of paper after 20 folds. So yeah, again, once you've written down the formula, which I really recommend doing, just writing down a formula to begin with for your nth term, because then you can just keep coming back to that formula if you need to use it again. So this time we just put in n as 20, and we get the following as our answer. And then we have to state one reason why this might be an unrealistic model. So with modeling, what you always want to do is look at your answers and think, does this make sense in the context? Well, this obviously is a very large, well, even though it's in millimeters, it's still quite large, obviously, for a thickness of paper. So we would state something like, it is not possible to fold a piece of paper many times, or a large number of times. Okay, or maybe just say something about, you know, you can't have infinite folding and like an infinite length, or something like that. Because obviously in this model, as n tends to infinity, so does the thickness of the paper. You can't have an infinitely thick piece of paper. So just think about what the context is, think about what's possible. And generally, when you are asked about if something's a realistic model or unrealistic model, just think, usually a lot of time you just want to think, well, what happens as n gets large? A lot of the time you'll find that actually when n gets large, the model falls apart. Not always. There's some models that it's fine for that, but in some cases it's worth considering what happens as n gets large, because often that's where the model will fall apart. Now, example 2, this is going to be a little bit of a longer example. Bruce starts a new company. In year 1, his profits will be 20,000. He predicts the profits to increase by 5,000 each year. He predicts this annual increase will continue until he reaches £100,000. He then models his profits to remain at £100,000. So firstly, what type of sequence is this? And are there any restrictions on this? Okay, so just want you to put in the chat, what type of sequence is this? But are there any restrictions on this? By the way, Gavin has put the link to the form to complete the test if you want to do that at some point. So what type of sequence have we got here in example 2? Are there any restrictions? Okay, so is arithmetic, is it always arithmetic? Yeah, so it's arithmetic until the 100,000. So what we want to do first is just we'll calculate the profits of Bruce's business in the first 20 years. So this is going to be the total profit. So what we want to do is work out how many years to get to 100,000. Okay, you could also work out how many terms to get to 95,000 and then just add the 100,000 on. That would also work. So what we want to do is find out in which year do we actually get to 100,000 for the first time, because once we're there at 100,000 it then stays at 100,000. So I use the following formula. So just as a reminder, this is the formula we're going to use. You do need to learn that. You don't get given it in the exam. So we're looking at when we get to the 100,000, we have our first term A is 20,000. Okay, remember this is an arithmetic series. We have a common difference each time. So n minus 1 here times the 5,000. And then we can just simply take away 20,000 from both sides. Divide through by the 5,000 and add the 1, and we'll get that n is 17. So in year 17, we find that that's the first time we get to that 100,000. So what we can do now is split this up into work out how much money we make over the first 17 years. And to do that, I use one of my summation formulae. So I'm just going to use the version where I do n over 2 times a, the first term, plus L, the last term. You can also use the version where you have 2a plus n minus 1d in the bracket instead if you wish. So we just simply put this on a calculator, and we obviously get quite a big number because we're getting thousands of pounds for 17 years. So we get to £1,020,000. So that's what we're making the first 17 years. For the last 3 years, you just get 100,000 for each year. So we just get 300,000 there. So your total profit, just add this together, and we just get £1,320,000. Okay, that's quite a big number, but it makes sense here. You're getting, tens of thousands of pounds, and then even hundreds of thousands of pounds towards the end. So having a profit that's a little bit over £1 million, that number makes sense. Okay, if you found that you had some number that was really small, say like you have something like 10,000, well, that doesn't make sense, does it? Because you get more than 10,000 just in the first year. So remember, it should be quite a big number here. What we then want to do, just check the chat in case there's any questions. Nope. So then the second part, say why the model might not be suitable. So we just have to kind of think about why this might not actually be the case. And really, it would be that it's unlikely to increase by the same amount, by the exact same amount, each year. Okay, so in reality, it's, remember, it's just a model, so it could be quite a good prediction, but in reality, it's not going to be, it's very unlikely a business would make exactly £5,000 more than they did the previous year. Okay, they might be getting, might be increasing, but it's unlikely it would be the exact same amount each time. So just have a think about that when you do that. Now there is a part C to this question, and that's that he says the profits are likely. So he's got a financial advisor, and he says the profits are likely to increase by 5% per annum. Remember, per annum just means per year. Using this model, calculate the profits for Bruce's business in the first 20 years. So what we have to do for this is we put A as 20,000. That's our first term in the sequence. R is going to be 1.05. Okay, because if it's a 5% increase, then your common ratio is 1.05 because your percentage multiplier is 1.05. So a lot of these modeling questions, you will be looking at taking percentages and writing them as percentage multipliers for your common ratio. So if we want to find the sum of the first 20 terms here, that's basically what this question is asking us to do. We use our formula that we met at the start of this week. So we do 1 minus r to the power of n on top, and then 1 minus 1.05 on the bottom. Just simply put that all in the calculator. And again, we should get quite a big number, not quite as big as before. If you think about it, it's only increasing by 5%. So before we said it was increasing like 5,000 each time. So for the early years, that 5,000 increase is much more significant than a 5% increase. So you would expect something a little bit less, even though when you get to the larger terms, it is starting to get bigger and bigger. And it will eventually take over that 100,000 towards the end. But that sounds like a sensible figure. Okay, £661,000 roughly. That sounds sensible. If you've got any questions, please pop them in the chat. If not, we'll move on to our final example today. So yeah, going to split this up into two parts just so I can show you everything and fit all the question on. So we'll do parts A and B first, and then we'll go and do part C. So the cost of Brian's new car, P, he accepted an interest-free loan of £P, which he agreed to repay by monthly instalments. The first instalment was £120. The instalments were increased by £5 a month, so that the second and third instalments were £125 and £130 respectively. So basically, we have an arithmetic series with a common difference of 5. Given that the loan was repaid in n instalments and that the final instalment was £325, we're going to show that n is 42, and then we're going to find the value of P. Okay, so very rare that you'd obviously get an interest-free loan. That's one of the things that makes the question a little bit simpler. So we're going to use the fact that A is our first term, which is £120. D is going to be 5. And we know that U20, that UN, is 325. Okay, our last term is 325, basically. So we put it into UN equals A plus N minus 1 times D. So we don't know N, that's what we're trying to find here. And with a little bit of rearranging, get the following, and we end up with probably just show a few more steps than normal, just because it is a show that question. Remember, with a show that question, we want to end up with this statement. Okay, we want to have our final line as n equals 42. Don't start with that and then work it backwards. Okay, with the show that question, it's almost like you don't try and act like you don't know the answer, and then that's what you should end up with by the end. So n is 42. And then we're going to find the value of P. So that's just the price of the car. It's an interest-free loan, so there's no interest being added to any of these payments. Basically, he's just paying every time he pays back. He's just paying off the cost of the car. He's not paying off the interest on it as well. So we just want to find the sum of the 42 payments. So we can just use n over 2, and I'm just going to use the simpler version, which is just a plus l in the bracket, because I know the first term is 120 and the 42nd term is 325. So what I get there is £9,345. Okay, yeah, again, does my answer make sense? Yes, because that is a sort of fair enough price for a car, isn't it? Okay, if it was a really small value, if it's something like £50, if it was something like £500,000, those numbers don't make sense. Around £9,000, that does make sense. The final example then, the value of Brian's car at the end of the first year was £7,200. After the first year, the value of the car depreciated each month by 2% of its value at the start of the month. So what I want to do in chat, can you write down, so this is a geometric sequence, can you write down what is my common ratio in this question? Chat. Excellent, so you've not fallen for the trap, you've all put 0.98, okay? It's decreasing by 2%, so it's 98% of what it originally was worth. So every time you're multiplying by 0.98. Okay, your first term is 7,200, and then depending on how we want to set this up, we'll call N25 here. Now be very careful. You told at the start you asked to work out what it is at the end of the third year. So if the end of the first year 7,200, the end of the third year, well, that's 2 years later. That's 24 months later. But if I'm doing this in terms of how many terms there are in the sequence, well, the first term is the 7,200, and then the second term is 7,200 times by 0.98. So just, you can do this different ways, but think of n here as 25 because there's 25 terms in the sequence, because say you've got 24 months of that depreciation, but your first term you've also got to include that's 7,200. So the 25th term is what I'm trying to find, because that's at the end of the third year. A is 7,200 times by 0.98 0.98 to the power of n minus 1, so that's 24. So yeah, again, this is where you can think of n as 25, but if you also think of, well, there's 24 compounding periods, depreciation periods, then you could just think of that n as 24 anyway. So whichever way makes most sense to you. So then work that out, and then, as we always should, make sure that we read the question very carefully. This does say nearest pound, so to the nearest pound, is 4,434. Okay, let me know if you've got any questions, but don't go anywhere just yet.